Well, welcome back, everyone, from the break. In case you don't know me, I'm Rich Brueckner from insideHPC. I've been running that publication for about 5 years now, focused on high-performance computing. And it's my pleasure to moderate this panel today. And we've got our sponsors up here, but I want to frame it in a proper way because once I was doing a talk in Taiwan, and they said, you have to introduce yourself properly. And the way you do that is first you tell the audience you're not worthy, and then you tell a joke. So looking at my panel here, I'm certainly not worthy to be on this stage with them, but I'll tell you my joke is I forgot my hat. I've been wearing the red hat here for years, and even before I was a reporter, and I left it at home on the kitchen table, and the looks of disappointment I got here at the PBS group yesterday wasn't good. So I was like, how can I get a hat? I'm in Mountain View where Red Hat is headquartered, where I got the thing originally, and I could not find one. So I went to Target. I got myself a white hat and a can of red Krylon. And we will be giving this away at the end for someone. Nice. So anyway, so what we thought we'd do today is talk about something big that's happened in HPC. It may be the biggest thing in 10, 15 years, and that is the executive order from President Obama and the National Supercomputing Initiative, something he formed with this executive order. One of the things that came out of that is they put a stake in the ground, we are going to build exascale machines in this country, and I think they put some dates to it. It's not funded, but it is a big deal. And of course, all our reporters, we didn't read the other 15 pages of it. We just glommed onto that exascale, but there's a lot more in there that pertains to this audience. There's things in there about programmer productivity. There's things in there about big data. And I saw a talk by Irene Qualters from NSF last week. Her piece of that with the productivity and making HPC more accessible to the scientists, that is a 25-year effort. That's part of this document being laid out. So those plans now from that the first plan is going to come out within 90 days of when it was announced, which is around August 1st. So we'll be seeing a lot more about that. But I thought today, what I'd do is have our panel members introduce themselves, talk about their area of focus briefly, and then solicit from you what they the questions they're looking for this panel. Because let's look at this more as a feedback session. If we set the clock for how are we going to move forward as a community of HPC, NSCI is the first time the government's having a coordinated effort around HPC. It's been all over the place. DOE's led pieces, DOD, all these agencies, academia. Ask this panel, the questions that are on your mind as we move forward. So, Bill Mannel from HP, why don't we start with you?
Sure. Hi, everyone. I'm Bill Mannel. I'm the general manager for HPC and big data at Hewlett-Packard. And I'm responsible for the HPC and big data business. I do have an engineering team that focuses particularly on the Apollo line, but I'm also in charge of HPC and big data across the entire company. So obviously, HP has a lot of product lines. So if someone sells HP blades with HPC, I get credit for it from that standpoint. So the sort of a very, very broad responsibility across Hewlett-Packard. And so I guess from my perspective, relative to the NSCI initiative, I'd like to get questions around, what kind of technologies and architectures do we think would be interesting? How do we enable them? And how do we make sure that we're able to make them broad-based enough to be useful?
Great. So Etienne DeGroot, I'm the director of our worldwide ISV relations for HPC, part of our technical compute group at Intel. And my role is really working within the software ecosystem helping them enable the evolving platform as we work with our OEMs to deliver these capabilities, and really finding out what are those capabilities that are needed for tomorrow's platform, and working early with the ISV community to help bring those things to market to get that full platform experience. And to add to the questions that we'd love to hear from you is, what are the problems that you guys are having today? If you had that wish list, what could you put in software solutions enabled by hardware that would really talk about the productivity challenges that we have going forward, and how do we basically just provide that better experience and better leverage of the cost of our overall solutions?
Hi, my name is Jason Coverston. I work at Cray been with Cray now for about 13 years, kind of known as the PBS guy at Cray. Been working with PBS since, I think, version 5.3. Helped port it to the Red Storm computer, the precursor to our current XC40 supercomputer. So pretty familiar with the internals of PBS. Transitioned recently to our sustaining engineering group, which is service, and really work closely with customers, helping them design or get the most out of their machines, design their how their work flows through the system. Get to go to a lot of exciting places. Spent my summer at Coast, trading the hot and muggy summer in Minnesota for even hotter and muggier summer in Saudi Arabia. Kind of looking for questions more centered around workload management, possibly, since that's really my focus at Cray, possibly related to what's some of the concerns with our current customers and going into the future, and possibly something around energy-aware scheduling.
Okay, Ben?
So my name's Ben Bennett. I recently joined SGI prior to taking over marketing, which is both channels and the verticals and the product, which is the definition of products, as well as working through the various verticals like oil and gas. Those folks work for me. Prior to that, a lot of you will know that I did some stuff for the UK government for 4 years, split between Cheltenham and a place called Fort Meade, which we don't really discuss too much, and they have a different set of problems that we definitely can't talk about. I guess the problem with going last is that, I had a list of things I wanted to know about. Bill stole most of them. But interestingly enough, the one thing he didn't talk about is what he mentioned in his enterprise tech interview a few days ago, and that's I/O. I read the full lot of the Obama report. It's nice to see the colonials waking up to the Chinese threat finally. But I think the elephant that's really missing is if we're having problems now with scalability, with our 100 nanosecond latency and 100 gigabit networks, and assuming that we're on petascale applications, if you look at the HP gradient, we're a conjugate gradient, nobody's actually sustaining a petaflop on that yet, and we want to run an exaflop. So, that's my 100 terabit network. So where's that coming from? So I'd be interested to see if anybody's got any good ideas there, because I would patent them. And generally, we talk about ease of computing. What are the stumbling blocks with getting the most out of the computational hardware that sits on your floor and depreciates at a scary amount?
All right. Well, audience, I have a bunch of canned questions, but I want to open it up to you, and they've told you what they're looking for, so who wants to go first? Bill's got the mic. All right, I'll get them warmed up. So let's just talk about NSCI short-term, long-term, and let's start reverse here. Ben, what do you think the effects are going to be short-term versus, out there a bit?
It depends if there's any money.
The money, yes.
So I think if there's money, then there's going to be a bun fight. There's going to be some proprietary hardware developed. And lots of people get very excited, and my concern is that it won't trickle down to the people in industry, the people that use machines, and you won't see the benefit for 10 years.
Yeah.
Now, that's because I'm cynical, and I've seen it before. Long term, I think the fact they want to focus on software is good, but it's a 25-year problem.
Yeah.
So.
Yeah. Jason, any thoughts? Short term, long term?
Yeah, well, long term, I think Cray is pretty excited about the initiative and what it brings for supercomputing. Short term, I think it's yet to be seen what it means for users. We'll continue really down the path of scalability and parallelism. But I really think something that we need to keep in the back of our mind, I guess something probably we don't necessarily think about as the builders of the HPC tools is, how do we make it easier and more efficient to analyze all the data. I don't so much mean about log and debug information, but how do we make or how do we assist the users and the scientists in helping them determine and draw conclusions from this massive amount of data. So.
Okay. Etienne?
Yeah, so short term, I'm just concerned just being a government body, kind of the chaos and the fiasco of it. But in parallel, we've been working closely with our OEM partners and ISV partners and creating standards and open capabilities where we can all embrace the platform and innovate and deliver together. So we think it's great. Long term, I think that we're going to have better alignment, more embracement about open standards, driving that innovation, talking about better user experience, all the things that this proposal is embodying. So I think it's going to be a little problematic for a while, but I think once we ratify that in the form of how we all play in a common set of rules and capabilities, I think it'll be a good thing. It's just going to take a while.
Take a while, yeah. Bill?
Well, certainly short term, I guess the challenge is the fact that obviously this current administration has roughly 18 months of existence left. So it's a kind of an interesting project to plant on the doorstep of the incoming administration, whoever that might be. So I think that's certainly interesting. The executive order does have a lot of bipartisan support, so I think that's very positive. So we're hoping that will project it forward into the next administration from that standpoint. So that's some interesting dynamics, just purely because of politics and the way our government is set up. I think a couple of the long-term interesting things, and this to Thomas, who talked earlier before, I like the fact that there's a healthy piece that talks about training and enabling of an HPC workforce, if you will. And that's actually a bit of a concern of mine. I have a quite aging workforce. I've got people that actually work for Convex, if you remember them, and quite a lot of people that worked for Digital back in the days. And these folks are probably 5 to 10 years from retirement. And I think some of the challenges are how do we get the next generation excited. And as part of my business, I do call on the cloud service providers as well, and you see all the young people coming in and all the colors and things like that when you're visiting at eBay and Facebook and all these other places, and how do we as an industry attract that talent and enable that talent as we go forward. So I think that's a critical thing that we need to address over and above technology and software and enablement and those sorts of things as well. How do we continue to make HPC an interesting thing to go into and keep it vibrant?
Okay. Well, let's see if the audience has sparked any questions for our panel. Robbie.
Just a question on not the other extreme, I should say, not the exascale. When somebody mentions HPC, obviously everybody thinks about exascale and huge scale problems, but there's tremendous opportunity, obviously. in small industrial HPC, and I'd like some feedback from the panel members, see what explicit, specific efforts they are putting forth to address the common HPC requirements, not the extraordinary requirements.
So I think, you mind if I respond?
Go ahead, yeah.
So I think it was Rich brought up, so I had talked to Irene Qualters, who's at the National Science Foundation, and so the National Science Foundation is pretty determined, if you will, to make this broad base, not about, one or two big leadership systems, and looking at all kinds of different venues for which we can SIP or sample HPC, whether it's through the cloud, so you don't need to make that internal investment in both resources and skills, whether it's something that's easier to consume, and we've talked a lot about software models and so forth that we can use. So I'm hoping as part of the initiative, we do keep in mind that a significant amount of development, especially in this country, actually happens in small and medium business, and we do want to enable them in the best way possible through the right kind of HPC in terms of price performance and usability and all those things as well.
Yeah, so, go ahead.
So I was going to say, some of the things that specifically happen with industry is that industry has a good dialogue with the HPC providers because they understand there is a value to the product they buy. And typically, they will pay for things that they believe are of value. So part of what there needs to be is a dialogue, is to understand what is the value. If you go to Lawrence Livermore 10 years ago to when Mark Seeger was there, he believed the value was you would leave a pint of blood with a pile of tin and walk away, and I believe we've had to move on from that, looking at the industry. So it's a case of, where are your pain points? I mean, we can build Coral type machines, but you don't need a Coral type machine. So it's trying to understand what is an appropriate solution and an engineering solution that you need. And those are the questions that we've been asking. What is it you need? What are the pain points you have? We can build you a Rolls Royce, but if you're shifting 14 tons of bricks, you want a flat loader. So, part of it is behooving on you, the customer, to clearly articulate what your pain points are so that we can provide you solutions that you're willing to pay for. There's no point building a machine that you won't pay for.
Yeah, so to add to that, I'm not sure how many of you were at ISC back in July, but Raj Hajra, our executive in HPC, announced a scalable systems kind of a framework approach where we're working with HP and other partners to really kind of define the standards of creating kind of building blocks that are interoperable, whether it's software or other hardware components, and really making sure that there's not only interoperability, but kind of creating that standards body to make sure that adoption can happen at a quicker pace going forward, while also delivering performance and robustness. So more to come on that going forward. But those efforts are in play now.
Jason,
Yeah, and I agree. Cray is definitely putting a lot of effort in leveraging a lot of our work in HPC and pushing into industry and especially in some of our cluster offerings and stuff like that. So.
Okay. Another question from the audience? Did I see a hand? Okay. Well, as I mentioned, the NSCI initiative has a big focus on big data, which I thought was refreshing because we see these merging with HPC, these workloads, right? So I want to go around and talk about your company a little bit, but what is the number one thing your company brings to the table for big data today? Bill?
Sure. So, probably what Hewlett Packard brings to the table is the fact that we do have a significant amount of customers that are using big data in the traditional sense in their enterprise. So a pretty significant enterprise business built around things like Hadoop and big data analytics and so forth. And obviously there's a large software component of the company that focuses just on that. We call it the Haven, which is the merge of Autonomy and Vertica some of our Hadoop elements as well. So we bring both a software perspective, a solutions perspective, as well as a hardware perspective into that mix. Now we're a large company, so we don't often come out as particularly synchronized across those three groups, but part of the end goal of the separation is to slim the company down and also force these very desperate divisions to work together better. As an example, HP does sponsor a big data conference every year out of the Boston area, which is actually, that's where Vertica and these other acquisitions we made over the years were centered. And for the first time, I actually and some of my staff got invited to be a part of that. So I actually were able to present a full solution story as we go forward. So we are working and bringing those solution elements as we talked about earlier. How do you make sure those things work together and work together in a way that is ideal for customers? And at the same time, we have our HP Labs team that is being very, very busy building what we call the machine, which is a new architecture centered specifically around a memory-centric type of computer. And so all the talk about the data and so forth and so on, the data is the center of that particular machine. And so we will start to see that coming out. In fact, in my Apollo line, we'll start to see elements of the machine coming to life within the next year or so. That will give us a sense of what that kind of capability can do.
Yeah, and to add to that, so from an Intel perspective, obviously we're an integration machine. We're taking more and more transistors and integrating them down into fewer chips and whatnot. And as we look at the overall platform, yes, we make microprocessors and coprocessors, and now there's faster I/O and new kinds of memory coming online and SSDs. So anywhere where there's a bottleneck to provide that big data experience, we're either investing or creating those building blocks that we end up passing to our OEMs to take it to that next level. So that's basically been in our DNA from day one.
Yeah, big data means a lot of different things. And Cray has a lot of offerings, analytics and graph analysis, Hadoop. And I don't know if I can really rank the importance, but we do have quite a new product coming online. It's named Data Warp. It's centering around data movement. It's accelerated I/O. Fast SSD cache, really close to the compute resources. And this is something that actually we've been working pretty closely with Altair, developing the mechanism on how, users can access this I/O. I think it really kind of highlights, a really good example of, the big problem with big data and, no real one company can solve it. It really requires collaboration, between companies like Cray and Altair. So, yeah.
So at Supercomputing last year, we demonstrated the UV300 machine, which was a partial collaboration with Intel and their SSDs. And in a single cabinet, we could put 32 sockets and address 32 terabytes of shared memory of RAM and 128 terabytes of solid-state disk. We ran some fairly interesting benchmarks, and in a single cabinet, we can throw around 200 gigabytes a second and 30 million IOPS. So we really think that we have a very, very good big data platform. Now that's just been extended. We can now go 64 sockets and 64 terabytes of RAM. And at the Smoky Mountains conference a couple of weeks ago, we announced a research project called the Zero Copy Architecture, where we have the ability to have a cluster connect to this Zero Copy Architecture box through PCIe switches, so that each node of a cluster thinks it has a solid-state disk directly attached. And there's a UV on the back end which sees all the data across all the solid-state disks. So the clusters can do ensemble work, and that data is available to the UV, and it never gets moved. So we don't have the I/O problem. It's all there, and the UV can read it and do the analysis. and the prototype is 1,000 KNLs and 256 SSDs, and the DOE, bless their little cotton socks, are going to cough up and enable that to happen over the next few years. So, and just as an interesting point, there was an article on the web recently about the term big data, and apparently somebody at SGI actually had a banner in 1993 at a supercomputing show solving big data problems. So that's the first time it was that we could find where it came about. So I'd like to think that we have a little history in it.
Absolutely. Right. I think I was part of that booth back at SGI Cray.
Oh yes, I forgot you're old.
Yeah. So, questions from the audience before I jump into the. Here we have one.
Yeah. So, as you know, I'm a HPC troublemaker, right? So, but anyway, I want to thank some of the vendors on the floor helped GE a lot, like on our HPC challenge. Appreciate for the partnership and the support. Thank you. But at the same time, I want to ask a question: like, how would you all vendors help the companies, industrial, academics, to react to the challenge of cloud? So let me give you the example. If I need extra capacity today, I need to write a PO, I need to wait for the product to deliver, our system arrive on the floor. It took a couple months. But if I do it on cloud, it will be like a couple hours before I will have an environment. How would you help your customers to get access to the extra capacity so that we don't have to necessarily rely on cloud, and some of our workloads cannot even go to cloud anyway? So I just want to hear the feedback on that.
So,
Let's go. Yeah.
So part of that depends on the vertical you work in. So for example, within manufacturing, we are working with a variety of ISVs that the applications will allow you to do burst out capability to the cloud if you need it. Do we have a one size fits all solution? No, but then I don't think there is one size of problem. Are we going to do what Sun did and build our own data center to allow you to burst out to us? A, we can't afford to build it, and B, we can't afford to lose that much money. So no. So we will work with ISVs, and I believe James might have mentioned it yesterday about PBS being able to burst out to the cloud, but I don't think that's going to be a public announcement. And let's just say it's a fair assumption that we would be part of that organization as well.
Sure. Yeah, so from the software industry, we're seeing that as a growing trend. You know, people either have the solution in-house or they have the solution on a cloud, whether it's Azure or their own data center. And speaking of data centers, it's funny, Intel back in, I think it was like 98, we actually built a data center right here in Santa Clara, bleeding edge, state of the art, and I think we were a little ahead of our time, and we ended up selling it for probably pennies on the dollar, and now it belongs to Citrix. But you know, it's an evolution, and I think we're going to get there where, you know, applications from a variety of vendors are going to embrace this flexible model for the very reason you described. People need to get something quick. They need to have that flexibility. They don't want to staff up both resources on different kinds of hardware for a short period of time. You know, you've got a job that's due, you've got a client coming in 2 weeks, you've got that burst mode situation. I think that's going to become a normal checkbox for people in IT to check the box when they are looking for solutions and hardware that's supported. But, you know, we embrace both. I mean, whether people go to the cloud or have it in their own data center, under their desk, in a workstation, you know, we're, you know, kind of that building block supplier. So we're embracing all models, but we want to make sure that things work in all directions.
So I think in, you know, as we look forward in terms of technology, so obviously the large cloud service providers are a significant part of the industry right now and growing, you know, more than any other standard type of market as they go forward. I believe over time we will see that there will be technologies that will come into play through the work of all of us and many of you as well, that will allow more players in that market, more ability for people to stand up clouds in a lot of different ways, and also make them more specialty. Because if you, what I do hear back and forth from customers that are using, for example, AWS as their mechanism, they're relatively limited in terms of the types of technologies that they can engage, the types of applications that they can engage. So I believe as the technology matures and it becomes, again, easier to use, you'll see more and more of ISVs, of universities, and so forth and so on, being able to build a cloud infrastructure quickly, cheaply, affordably, economically, and so the environment itself will become much more copacetic to that kind of arrangement. So as opposed to now, you see a lot of vendors who want to put stuff on premise, and then you have AWS over here. I think you'll see a much wider spectrum of folks through the middle. Some of them will be very specialized. Maybe you'll see HPC specialized providers, and as we all know, that more and more of us want to sample from that, so the economics become better. Then you'll have maybe more and more general purpose to Amazon over here, or Google and so forth, that are very general purpose from that standpoint, with a lot of the trade-offs. So I think the industry will grow, the technologies will replace that gap, and we'll be able to enjoy much more of the fruits as we go forward.
Yeah, and just to add to that real quick, so at Intel we've got a series of folks that are working with all of the cloud solution providers, whether they're the Amazons and Azures of the world, or they're tier 2s, and we're all seeing this explosion in tier 2 space. And we're seeing examples of, in Amazon, it's kind of like Southwest Airlines. Everything's a 737. So if a customer has something that's a different kind of a requirement, sorry, today that's not the model. That probably will change over time, but we're seeing a lot of disruption in the tier 2 space, where if you have a certain brand server inside your premise, and you know that works in your environment, but you want that burst capability, you can select what brand OEM, how many cores, threads, memory, etc., what solutions, and all of that to really mimic what works extremely well. So we're seeing that as kind of this grassroots effort that's starting to happen in the tier 2 space. So it's kind of exciting.
Mm-hmm. Yeah, I think Cray will continue to be part of the private cloud, and in the future, as the infrastructure does become more sophisticated, I think we will see the possibilities really are immense. But where applications are sensitive to latency and scalability, we'll continue to see the focus, I think, where in the private cloud segment. So.
Great.
So there was an interesting thing in the data tech last week that Microsoft were talking about, saying that they believed they were pulling more people away from the Amazon cloud, because what they were doing is they were taking models of machines and talking to their customers, and they said that even though it's a smaller tier, there's PAS, there was more money there than Amazon, and that they were actually using the Amazon cloud to do the development of their tests and building the models that they could then deploy as part of Azure. So that was the first time I'd actually seen. Well, it's not the first time I've seen Microsoft do something smart, but it did actually appear to be a leadership position for Microsoft, which perked me up a bit.
Yeah, that is.
Because I've seen Windows 10.
Oh, yeah, I was supposed to ask you about Windows. Is this the time, Ben?
No, Windows are fabulous. You can throw bricks through them. I would recommend you do before you put Windows 10 on your machine.
All right. More questions from the audience? Here we have one.
So I'm one of those sysadmin geeks referred to, and I've heard a whole lot of references to big data, but they almost always seem to be associated either with IT, with enterprise, business information, or occasionally with bioinformatics. How do science researchers, other than bioinformatics, take advantage of big data? Or let me get a more concrete problem. Say we have people at NASA who are doing parameter studies, 10,000, 100,000, we don't do that many yet, runs on configurations, aerospace configurations, okay? And as people mentioned yesterday, they're not going to look at each of the outputs, okay? The outputs will go into a database where they can be reviewed later, but they're not going to look at them individually. Are there tools available for big data now where they can take this Fortran output, plop it in some package, and click on a button that says, tell me the interesting stuff in this data, in this pile of data I have? Are there tools to do that?
So SGI produces a product called Mindset, which even if you just throw the top 500 into it, you can pull out some interesting relationships. So yes, it exists. Is it a universal panacea? No. One of the things that's happening at in the weather industry is they're doing more and more ensemble runs. And as you say, they get lots and lots and lots of data. Now, there's some experiments going on with a couple of places in Europe where if you can take all that data, hold it all in memory, and then use a UV to look for differences and just visualize it, just literally look at a big two-dimensional array where each line is the data, and you're looking at the difference between the data as just like a LOFAR display in sonar. You can pick out some very interesting patterns from the runs and draw a mouse around it and say, let me go look at that. Why is that different? Why is the difference so big here? What are the input parameters in the ensemble that cause this deviation? But that takes a lot of memory and a lot of processing.
And so from the Hewlett-Packard side, we will be making some announcements over the next few months or so of some new developments we've been doing in HP Labs as a pre-up, if you will, to the machine. So the big question around the machine from a lot of our customers who saw it was, interesting architecture, but how do I get stuff in? How do I get stuff out? How do I get interesting value out of it? And so we will have some announcements. Those tools will be running on my Apollo platform. In fact, are running today. But those are tools you'll be able to manage your big data in a way that a lot of scientists are familiar with. So very similar semantics to MATLAB or R today is what one of the objectives is to make it easy enough. And the labs guys, the lab software guys have a lot of examples where very short number of lines that are at least somewhat recognizable. You can do a lot of work on a big chunk of data from that standpoint. So that is something we're trying to do, obviously.
Yeah, I think you touch on a really good point because with more and more data, it's just becoming really impossible to have people interpret the results. So developing tools to, I think I mentioned this before, keeping that in mind. Developing tools to help and assist with analyzing this data is going to become really important, I believe.
I hope we're going to see something out of the commodity space, because when 3D Crosspoint hits, the Crystal Ridge technology hits your PC, and you have effectively 4, 5, 6 terabytes of RAM, you're never going to delete anything. Consequently, you're never going to be able to find anything. And so therefore there's going to be a need to do ways to look through all this data, and if you know how to use grep and you know how to use pipes, you still can't find it. Think of the poor bugger that's got File Manager, and it's got 2 trillion files he's looking at, So I'm hoping that somewhere out of the commercial space there are going to come some more tools. I mean, we have seen improvements in the debuggers because of the massive number of threads. That sort of technology is going to have to end up on your laptop, on your phone, once Crystal Ridge hits. Thanks, by the way.
Yeah, no, it's exciting stuff. I mean, this is part of the evolution of the platform, new kinds of memory and whatnot. And We're working with the greater software ecosystem to have them put hooks into solving these kinds of problems. So the people are looking at this today. So we're working closely with them and giving them early access to this technology that comes online to solve some of these problems that we're hearing about. So, the more we hear, the better we can work more holistically together.
All right, we only have like 2 minutes, so we have time for one more question. Michael.
So this is for question for HP, SGI, and Cray. All of you are basically buying the same components from Intel, same SSDs, same spinning disks, and so forth. How do you differentiate yourselves for more the industrial HPC? Not top 500, not $1 million machines, but how are you differentiating for what the speaker from GE spoke about earlier?
Let's start.
So in the UV platform, we obviously have the Numalink technology, which allows you to go out and scale memory beyond the socket. So as I say, currently the UV300 on the Haswell timeframe will support 64 sockets, 64 terabytes of RAM. So in one sense of differentiation, nobody else can do that or scale that way. So, we look upon UV, and then of course we have certain packaging benefits with ICE-XA. These are the incremental bits where if you look at every problem and you take 1% off, you make some differences. So that's really where we differentiate.
And I really think we, again, can leverage a lot of our, experience with scalability and bring it into industry. I think, some of what we're doing with resiliency is important in especially in the Fortune 500 space. So I really think that is some of the things that we can bring to that segment.
And from a Hewlett-Packard standpoint, we, over the past few years since Meg Whitman came back, or not came back, but came over, we've put a lot of energy into new development. So we are doing quite a bit of work in the HP labs, for example, and we'll continue to do that level of work, both from a software as well as a hardware perspective. So you'll be seeing more and more announcements from us over the next few quarters to few years as we go forward with that. The other thing that HP does offer is a degree of scale that a lot of our larger customers need. So if you're an international business, an oil company, and you need 24/7 support, and we've had this happen: Nigeria, Malaysia, Houston, and London, all at the same time with the same level of capability. That's something we're able to do that a lot of other companies aren't able from that perspective.
And I'll just chime in from the Intel perspective since we're kind of in the middle of it all. But, we'd love to see all of our partners kind of go and widen the market. I think that's good for all of us versus, fighting for the same deal, so to speak. So, like HP and others, we have a lot of R&D efforts with our labs. And some of these things are amazing. Some things don't come to market in the form of a product that we can sell to an OEM. But we're always looking at ways, working with government, working directly with end customers, trying to find new solutions to new problems and hopefully expand that market. And then how that plays out, is up to our partners. But that's an ongoing effort that we have.
Okay. Well, I think we've run out of time, so why don't we give our panel a big hand. I think they did a great job.